Welcome to the Nothing Nerdy presentation, Everything Electric. Episode 1, Chiefly Charge. Electric charge is something that moves around an electric circuit. Here you can see the charge coming from the battery through the wires and it's lighting up the bulb. It's passing through an object at the bottom of the picture. In this case it's a paper clip, but we're going to replace it later with an eraser, with a coin and with a human hand. What does the result look like? Well, here's a result. We've got scissors, we've got paperclip, pencil sharpener, drawing pin. They're all conductors. Obviously the light lit up. The pencil is in the middle, and that means that it's not a very good conductor, probably because the graphite in the middle of the pencil didn't conduct very well. On the other side, we've got insulators, and they're bad conductors. That means the light didn't light up. The examples here are paper, plastic, the eraser, and the ruler. We can collect electric charges together by friction. We rub substances together. You may have experienced this yourself. Your body is a conductor, and if you have friction with a particular object, such as a carpet or some clothes, then you may get an electric charge on yourself. You will only notice this when you touch another conductor and you share your charge with that other conductor, and you may get an electric shock. Insulators are slightly different. This balloon has got an electric charge by rubbing against the sweater. The minuses have collected on the balloon, but it's an insulator, which means they don't go anywhere. They just sit there on the balloon. Electric charge is carried by electrons, and electrons are negatively charged particles. Here, for example, the electrons have collected on the balloon, and so the balloon has a negative charge. The sweater has a positive charge because it lost electrons. The explanation for electric charges are usually in terms of electrons. The positives don't move, they just stay where they are. All electric charges have forces between them. For example, these two positive charges are repelling each other. The forces are equal and they're in opposite directions. In the next situation, we've got opposite charges, a plus and a minus, but the forces are still in opposite directions. The difference here is that they are attracting each other. Lastly, two negative charges repel each other, equal and opposite charges once again. Here's a summary, and the rule is that similar charges repel each other and opposite charges attract each other. Why does the balloon stick to the wall? The wall contains atoms, and those have electrons and nuclei. The nuclei are positive charges. The electrons will move, but the positive charges will stay fixed where they are. That means that when we bring the negatively charged balloon close to the wall, the electrons in the wall are repelled, but the positively charged nuclei stay where they are. The effect is that the charges are separated and the surface of the wall becomes positively charged. We call this electrostatic induction. You can see that the charges on the wall still add up to zero, but they've been separated. The result is that the negatively charged balloon is attracted to the induced positive charge on the surface of the wall. A Van de Graaff generator is a very exciting piece of apparatus which we have in the physics lab. It creates a large static electric charge on an insulated metal dome. Here's a picture. You can see that the positive charges are travelling up the belt on the left, and they're being deposited on the dome. The dome is insulated by standing on a plastic column. The charge will now collect on the dome, and you'll get quite a lot of electric charge. You can release it if you bring another conductor close, then there may be a spark and the dome will discharge. There are dangers to static electricity. Really, there are two. One is dangerous sparks, which can give you an electric shock. The other is that you can get a fire. Here is a picture of a large spark travelling between the earth and a cloud. Lightning is obviously a danger of static electricity. There are real dangers also on the airfield. If you refuel an aircraft, there can be petrol fumes, and if there is a spark, they can be ignited. Aeroplanes sometimes gain static electricity while they're flying. How do we solve this? With a cable like that. When the plane lands, you can clip the cable between the aeroplane and the ground, and so if there's any static electricity accumulated on the plane, it'll run away before you start refueling. There are benefits to static electricity as well. The photocopier works that way. Here's quite a complicated diagram. You'll often see this diagram with the pluses and minuses reversed, but the idea is the same. It contains a metal cylinder, which is called a drum, and we give that an electric charge, as in picture 1. On diagram 2, you can see that the light is shining on the drum. Where the light shines, the electric charge will be removed. Where no light shines, that means there must have been a dark part on the original image and the charge will remain. We now give the black toner an electric charge, and it sticks to the drum in the places where there is electric charge. It means that there is now an image not in charge but in toner on the drum. Lastly, we pass paper across the drum. The paper also has an electric charge, so it attracts the toner and you get a picture on the paper. Lastly, we raise the temperature of the paper to pretty hot so that the toner melts onto the paper, which is why photocopies are warm when you first receive them out of the machine. Another use of static electricity is in the inkjet printer. Here's how it works. There is ink in the reservoir at the bottom of the diagram. We pump that through the nozzle and that squirts droplets of ink towards the paper. Now that would leave a dot, but what we do is we put an electric charge onto the ink and then pass the ink between the deflection plates. They can have a static charge, so the stream of ink is now either attracted by the plates or repelled by the plates, and that'll make the stream of ink go up and down. When we move the paper left and right, we can actually place the dots in very precise places, and so we can write letters or draw images on the paper, and you'll find that about 100 dots go together to make a single letter. It's a very precise piece of apparatus. Here are two more uses of electric charge. One of them is called electrostatic painting, and a metal object can be painted by a spray gun. The paint has one electric charge, the metal object has the other. The advantages are that you don't waste much paint, and also very strangely shaped objects can be painted in this way. Electrostatic precipitation is a way of removing pollution from the air. So smoke particles from an industrial process are given an electric charge as they go up the chimney, and then an opposite charge attracts them before they get out into the air. Thank you for listening to Chiefly Charge. I hope you enjoyed the program.